Most of the AI engineer's job is not to work on AI model, rather to work on data. Why? Because it is being said, if AI is a machine, data is fuel to it. Now let's understand this thing in a deeper way.
So here if you see, we're trying to predict customer behavior, like what the customer is going to purchase next, or what we're going to see on the recommendation section if someone is buying on an e-commerce website. Let's say you're going to buy a sofa, the Amazon shows automatically the sofa cover, right? So to process those kind of data, we need to get the records first of the customer. So here if you see, if you're going to pull the records from the database, so Rahul Sharma, Rahul S and Priya. For the example, we have 3 records, and this is the AS, city, and purchase amount. But if you see these records, there are few problems in processing those records to a model. What are those problems? Starting with inconsistency. Here, if you see, we can read Rahul Sharma, Rahul S. For a human, it does make sense. If you go to the age, also it's 28, 28, and Bangalore, Bangalore, Bengaluru. For a human, it makes sense. But for a model, if you go, this is Rahul Sharma and Rahul S. They might be same person, but model will consider them as a separate entity. Here also, if you see, the age is a number and here age is a string, text basically. So if you're going to calculate any numeric operations, models, if I tell you, these are just mathematical formulas, so they don't understand text. So we have to convert everything in a proper manner. And here if you see, Priya forgot her name, sorry, here if you see, Priya forgot to enter her age. So this doesn't work. Here if you see Bangalore, Bangalore, even if the cities are same, again the model is going to behave like these are 3 different cities. One more thing, if you see, if you go to the purchase amount, if you see, this is rupees 1500, this is only 1500, and this is $18. So rupees 1500 has a prefix and 1500 is just a number, here $18. So if you just remove rupees and dollar from prefix, things will be very different, right? Because the model is going to think $18 is less than 1500. So here you have to consider, you have to keep the scale same. If you're keeping rupees, you have to keep making the entry in rupees. If you're keeping a dollar, you have to keep making entries in dollar. And you cannot have missing data. Missing data doesn't work for mathematical formulas. That's why you have to populate those missing data, so this can understand, AI model can understand, or neural network can understand and work mathematical formulas. We have to populate. There are different methods. If you have worked on pandas or PySpark, there are different methods you can work on. So here basically, if you take the raw data from the database or anywhere, you cannot process that because this has inconsistency, wrong formatting, missing data, and different scales. And these are the things are not going to work for the AI models. So the very first thing is raw data we cannot process. We have to process the data fast, make it even, make it clean, and then we have to process. And that is why most of the times of AI engineers goes on this process. Now let's talk about the training of an AI model. For example, let's take an AI model doing sentiment analysis. What does it do? Let's say we have an e-commerce store and it has a product, let's say earphone. And for that earphone, whether it is the product is good, average, or bad, it has to predict. Now how it is going to predict? By reading customer reviews. Now when customer reviews has words like awesome, value for money, high quality, now that product is supposed to get predicted as good. When there is words like okay, not bad, average, that word supposed to get predicted as average. And when there are words like horrible, bad quality, or poor, the model should predict bad. So what initially is being done is we provide, so these are the input data, and these are the output data. So what happens initially, we train the model by giving all the input data as well as output data. So we train the model, say, see, this kind of, when this kind of words comes in, you go for good. When this kind of words comes in, you go for average. When this kind of words comes in, you go for bad. So this input when we give, these are called feature, and the output that we give, those are called labels, which will be expected. So let's say we train a model with this kind of data and this kind of data. Now it's the testing. Once we train the model, there is a phase of testing. So let's say for the testing, we enter a customer review which says, wow, just great, the delivery took exactly 3 weeks and the box was crossed, outstanding service. Now here is the game you need to understand. Here if you see the words outstanding and wow, those are basically the words that's supposed to predict the level good, isn't it? But if you see the exact meaning of the sentence, it shows sarcasm, which means negative. But the AI model doesn't understand sarcasm. As a human, you can understand sarcasm, but the AI model doesn't understand this. So what happens, this kind of review actually tests whether an AI model is good or bad, and this kind of sarcasm actually tests an AI model, and this kind of sarcasm which makes the AI model fail. And that is why AI model is never 100% accurate. So after training, we measure its accuracy. We test it on many reviews where we already know the correct answer and count how many it predicts correctly. If the accuracy is low, we know we need to train it further to give it better data. Now let's talk about training data versus testing data. Let's say we're doing a email spam prediction model, which is if an email has words like free or win, it is going to check, and it's going to check number of links in it, and on the basis of that it's going to answer whether it is spam or not spam. So for now, let's consider this is training data. So training data means we have to give the model both feature and label, right? So first, it's going, if the email has you own a free prize, then own is there, so it's going to check yes, and it has number of links 4, so it's going to, so the model is supposed to predict spam. Lunch tomorrow has no free or win, number of links also 0, so it's not a spam. Claim your free gift now, so it has free, so free or win, yes, it is there, number of links also there, it is 3, so it is a spam. Now another email said, here is the report, there is no free or win, there is no link, and it's not spam. So this is training data, and we trained the model with this kind of data. Now we have to test. So for test, our data should be different. Our data should be not similar to the training data. Here if you see win free money, here win is there, but links we have reduced to just 2. Here also if you see you at the meeting, there is no free win, but there is a link because there is a meeting link available. So we have to see if we predict this kind of input, what the output is going to come. So on the basis of that, we're going to decide the accuracy of the model, how accurate is the model. If it is not accurate, we have to take different actions on top of it. So let's say we have a data set of 100 records. So it is being advised that the training of a model should be done with 70 to 80% of data. 70 to 80% of data should get trained. Another 20 to 30% of data should be testing data, which is basically this 20% data model should not have seen before. So those 20% of data should be given while testing the model. So we have to prepare a data set. From that data set, we have to divide 70 to 80% as a training data and 20 to 30% is a testing data, and this testing data should be fresh and should be provided in order to see how the model is behaving with the new set of data.